All right, everybody should be able to see my screen now. My name's Dave Strabel, so I am a open source specialist on our global black belt team. So areas we focus in are really open source cloud development, microservices, containers, really add any other buzzword there and we probably cover it. So today I'll be talking about Azure Container Service, also known as AKS now. So in this, we'll kind of go through where we are today with ACS and kind of also where we are in the future, and then also go through some of the components within Kubernetes, and then also go through a demo. So if you look at containers, I'm sure everybody's heard of Docker and containers. And a lot of times within organizations, this is kind of how the conversation starts out. Somebody hears all the goodness that containers is going to probably provide them, but should you really care about actual containers? And the answer is really no, you shouldn't in reality care about containers, because what we're really caring about is really about cloud native applications. And there's multiple reasons that we've kind of taken new architecture patterns towards cloud native applications, being it, unlimited scale, global reach, time to market. And, with these cloud native applications, they're not really a free lunch. They also bring in other complexities here. A lot of organizations aren't just going towards cloud native applications because it's a cool thing to do, but they're being forced to do this to innovate faster. So when we think of containers, they're really kind of just a nice little artifact that allows us to really package up our application in better ways than we did before. But what really matters on top of that is the orchestrator. And the orchestrator, that's where Azure Container Service comes in. So if we look at what Azure Container Service is today, it's really about more of a managed delivery. And I use that word delivery deliberately because it's not really a managed service. It's more of managed delivery of an optimized hosting solution. So being that it goes out, it can deploy both Kubernetes, DCOS, Docker Swarm today, and we'll do that to best practices, and there's not much that you have to configure there to get that up, but it's not a managed service. So we have full support from Microsoft, Docker, and Mesosphere. So Mesosphere is where DCOS comes from. We can also leverage some of the different Azure platform capabilities such as security and networking. So about a month ago, we released what's called Azure Container Service, and you'll see that it's also been kind of renamed to AKS. That's to emphasize really Kubernetes in there. It's not called Azure Kubernetes Service, but the K is in there to emphasize the focus on Kubernetes here. So what this does is actually delivers a managed service for Kubernetes. So you no longer have to manage the control plane. The control plane's fully hosted in Azure. When you deploy the service, you don't even see that control plane. The nice thing, you also don't have to pay for those resources for that control plane. With traditional ACS, typically you're going to deploy masters in a set of 3 or 5. Because it does use Raft for its consensus algorithm. So now no longer do you need to pay for those resources. It also brings in a lot of nice features around automated upgrades. So now to do an upgrade of that actual cluster, you just need to put in one command and it'll upgrade to the newest and latest version available within AKS. So it really eases the management of Kubernetes. And this is a lot of what we heard from customers, that they didn't really want to manage the orchestrator, but wanted that provided as a service to them. Again, on some of those different AKS features, so everything from that control plane is Deployed in an HA manner, we also back up, restore that. So all those things are lifted off your plate. You no longer have to focus on those. You can now start focusing what you build on top of Kubernetes. Some of the things we will have at GA is customized networking around VNets and the container network interface. Today there's cluster scaling in there. So if you want to scale your cluster, so scaling your agent nodes within your cluster that your applications will run on, that's again just another command that you can send to the API that will expand your cluster. Things that we will be looking at for in the future are things around TLS that's backed by Azure Key Vault, some Azure AD integration, and hybrid clusters. So the hybrid clusters is future state. Today, you can only deploy Linux containers on Kubernetes. In the future, you'll be able to do Windows also into a hybrid cluster where you have a single cluster that may consist of both Windows host and Linux host. To discuss a little around the Kubernetes architecture and the different components to kind of show you what we manage compared to what you'll actually see when you deploy this service. So all the master components are Azure managed components. So the API server, etcd, control manager, scheduler, those are all master components within Kubernetes that Azure will manage. The node components is what you'll see when you deploy the service. So you'll see all your nodes. On each node, you have a kubelet. You also have a kube proxy, which exposes services within your cluster. You'll also have you'll see DNS in there, and the Docker daemon will be installed on each and every node there. When we talk about the different resources that you'll deploy to Kubernetes, just to cover a couple of these is a pod. A pod is really your smallest unit of deployment. A pod can consist of multiple containers or just a single container. You also have replica sets. So if you need multiple replicas of a service when you deploy it, so you need multiple pods, which contains your containers, you can also set those within there. You also have things like ingress controllers, so you can do layer 7 load balancing within your services in Kubernetes. You also have namespaces within Kubernetes that allows you to kind of slice and dice your cluster logically, where you can set resource limits on different namespaces. So you may have namespaces for dev, staging, and production, and those can have all different kind of resource restrictions on them. So to get into a quick demo here of AKS, okay, so to create our AKS cluster, what we're going to use is Azure CLI. So when we use Azure CLI, the first thing we need to do is actually go ahead and create a resource group. So if we create a resource group here, so our resource group's created. Now we use the AKS create command. With the AKS create command, we give it our resource group that we just created here. And then we also give it the name of our AKS cluster. So you can also set things in here if you don't set a SSH key, so one that you already have, it will create SSH keys also for you, where you can pull down the credentials. So I'll just create this. That'll take probably about 5 minutes. Since we don't have time to wait for this, we'll just look at a cluster that I already have set up here. So a cluster I already just deployed, what it will look like, we'll use the kubectl command. The kubectl is really how you're going to interface with Kubernetes. So kubectl is the CLI that's going to talk to the Kubernetes API. So we can get and see what nodes we actually have deployed here. As you can see, I have 3 agent pools. So the agent pools are what's going to run all my applications. And this will give us also the version. If we use the AZ command here and do AKS list, we can also list all our clusters that we've deployed in here. Let me output that a little different. So you can see I have a newly deployed one that I was just deploying there that is in creating here. You can see that's on Kubernetes 1.7.7, and my other cluster I have here is on 1.8.2. All I needed to do was perform an AZ AKS and do an upgrade. This command right here will go ahead and upgrade my cluster to the latest version that I specify. So you'll have multiple versions. I believe 1.7.7 is the default version. That's a stable version of Kubernetes. The latest release is 1.8.2, but you'll also have some intermediate releases in there, like 1.8.1 also, that you can use. So let me just clear my screen here. How we can also interface with this cluster is through the dashboard. So to get the dashboard up, it's just going to proxy a request to the actual dashboard. So I just do a kubectl proxy. This will set up so I can actually just do I have the URL here. Now you can see the Kubernetes dashboard. The dashboard is going to give you some basic information of CPU usage, memory usage of your cluster, your different namespaces that we talked about, where you may have different namespaces for your dev environment and your staging environment. We can also see any type of workloads that were deployed here, different type of node information. Here we can also dig into. You can also dig down directly into that node to get more details about that node. Things like different allocated resources, how many pods are allocated to that actual node within your cluster. So I'll stop here and ask, is there any questions out there so far?
Yes. So Dave, I can see a couple of questions in the chat window. Do you want me to read it, or do you have access?
Yeah, if you could go ahead and read it, would be great.
So the question from Robert is, how does the K8 cluster upgrade impact agent versioning? Do we check consistency?
So so when you do an upgrade of AKS, what it's going to go through, it's going to go through each node. It actually, when you do the upgrade, it can take kind of a while because it's going node by node. It's going to look at what your master version is. It's going to make sure that you actually have the correct version there. It's going to cordon that node, so it's going to send a sig term to any of those workloads on a specific agent. Once that node has been drained, it's going to go through the upgrade. Once that node comes back up and it's ready to schedule new workloads, it will go through the next node within your cluster. So for like a 3-node cluster, that may take you anywhere between 15-20 minutes. Because it does go slowly through there and does do a sig term so it can drain that actual node and any request on that node. And there's things where you can set in Kubernetes how long it will take for like the SIG term. If you want that, wait 30 seconds, you want to wait 60 seconds. So it doesn't actually send a SIG kill to your applications.
Okay. So Dave, I have another question on the same lines. The question is, when the K8S is going through the upgrade, does it have any impact on our services that's running on the cluster?
So that's going to be, that's very dependent. You got to think about using replicas. So if you deploy a pod and it has a single container and has 0 replicas, what it's going to do is actually take down that container. It will then schedule it on another node as long as you set that replica. But let's say you have a pod that has 3 replicas, there should be 0 impact to that service.
Okay.
Yeah, so you just have to make sure that you have multiple replicas of your service.
Okay, perfect. So I see another question from Robert. What about checking Kubernetes version compatibility against the Docker agents, or is it irrelevant?
So that's not really relevant because the Docker agent is just on Docker 1.12. It's not going to go through and upgrade that Docker agent. Reason being because Kubernetes only supports Docker 1.12 currently in stable releases.
Okay, perfect. So these are all questions that we had in the chat window.
All right. So one thing I'll also show here is actually deploying an application to here really quickly. So what I'm actually going to use to deploy an application to this cluster is Helm. So if you don't know what Helm is really a package manager for Kubernetes. So you can think of it as almost like apt-get or Yum in the Linux world. So here with Helm, I can search. There's pre-made charts for you for specific applications. So I can do a Helm search, and we'll just search for WordPress. As you can see, I already have a WordPress chart here. So I can go and do a Helm install. And this is actually going to install a WordPress environment for me to my Kubernetes cluster. Oops.
You misspelled WordPress actually. W-O-R-D. You didn't type D.
Oh, good catch. Okay. So there's actually 2 components to Helm. You'll have the client side, and as you see, this says it can't find a ready tiller pod. I didn't have the tiller pod, which is the server side. That's what kind of manages the actual deployment to Kubernetes. So we'll try this again because it doesn't take that long for that pod to come up. So now you'll see that it's deployed this application, and here it gives back some of the information of what it's deployed. So it's deployed the actual pod. So it's deployed MariaDB, WordPress. It deployed secrets. So you can, Kubernetes has this concept of storing secrets within there. So it stores them in etcd. So things for like our database password, it can store a secret and then pull that environmental variable. Here it's actually pulling from a config map. A config map is basically mounts it to your container and pulls any type of environmental or configuration type data for you. It's also deployed some different persistent volumes for us. It's also set up a load balancer. So this load balancer, as you can see, is pending. What it's actually creating there is an Azure load balancer to expose our service to external traffic. We can also set that because Azure load balancer is really like layer 4 load balancing. If we needed something like a layer 7 load balancing, we could have a ingress controller with like Nginx, and there's a lot of other different ones that you can deploy there. But we also have the ability to do that. With Helm, it's always going to give you some information that's going to output here of how to access that different service. We won't be able to access the actual service. The load balancer usually takes a minute or two to actually deploy. But just to show you within our cluster,
so Dave, you are saying that you have deployed a complete WordPress environment on Kubernetes cluster in like 10 seconds?
Yes.
This is magical, because if you all have deployed WordPress on Windows or Linux, I mean, it's a lot of work to do. So you have to install the WAMP or LAMP, and then configure MySQL and do all that stuff, and you just deployed your WordPress and highly available multi-instance in like 10 seconds. This is amazing.
Yeah, in these charts, there's already a lot of created Helm charts for you. And if you're not familiar with Helm, Helm was an open source project created by Deis. The Deis team joined Microsoft quite a few months back. And they have a couple different tooling that you can use around Kubernetes. One being Helm, another one called Draft, which will help us take going from our code to building Docker files for us and building these Helm charts based on our code. So a lot of nice tooling around that. We can also go in here, and if you want to scale your service, currently I have one pod. Usually you're not going to do it through this, but for demo purposes, I can show this. You could set it up so now it actually has 3 replicas that are actually going to be load balanced. All right, I know my time is about up here, so is there any questions that you have?
I don't see many questions. However, I think I see a follow-up question from Yusuf. The question is it fair to state that the upgrade process is same as what would be in the case of standard ACS? I think probably it's trying to compare the upgrade process with ACS.
Okay, yeah, the upgrade process for AKS is kind of the same way as ACS. It's going to be a little easier, and you have different versions that you can easily choose from there. If you use the AZ command line, usually it's going to list what upgrade capabilities you have, meaning that you can choose those different versions. Where ACS deploys the stable version, the latest stable version of Kubernetes. Where AKS, you're going to have multiple, like the newest versions out there that you can go to. That doesn't mean you should, but you do have those capabilities. So maybe in your development environment, you want to try out new features that were delivered in 1.8.2. You can easily do that.
Okay, great. So another question is from BAT Michael. The question is, do Kubernetes secrets integrate with Key Vault?
So currently they do not as of today. We are working on that integration, so you can pull that secret actually from Key Vault. And one thing also to note, in newer versions of Kubernetes, secrets are encrypted. Previously, in Kubernetes, secrets were not encrypted within etcd. So you need to make sure that you enable that if you're going to use encrypted secrets. There's also other tools like HashiCorp's Vault that you can use with Kubernetes to store secrets.
Okay, perfect. So I don't see any other questions. It was a great session. Thank you so much, Dave, for joining us for this. I think this was very informative.
Hey, no problem.
Yep, and thanks all for joining us for Azure Power Lunch, and we'll continue to bring more sessions for you all in upcoming weeks. You all have a wonderful day. Thanks.